All right. Thank you all. Good afternoon. Sorry for the delay. We had some issues that had to be fixed before I start. So I apologize for keeping you waiting. And okay. So this weekend we want a few of you to take the examination and share your experience with the class next week. And so those of you who will be selected for that, you'll be given some few materials to read on. And after that, you take your practice tests and then you take your examination. So we may have a class tomorrow. We'll confirm that through email. And then those who will be taking the exam, you'll be given some topics to read. And after your practice test, your exam will be scheduled either over the weekend or early Monday morning, so that before class, you share your experience with the class. So that is what is going to happen. And good afternoon to you all. Good afternoon. All right. So thank you all for waiting for me. I'm here and welcome to another wonderful session. Today we want to continue with our lessons. And everything we are learning here is super important and will build you in terms of your knowledge in computing and cloud and tech, and will also prepare you for higher education. So if you want to learn more, understand modern tools, this is a great course for you. And we've been learning so hard. We've been covering several services in AWS, and we have learned a lot. This is day 15. That means we've covered so many services already. All right. So thank you all for following the course as it is, and it has been designed to help you get better understanding. So let's keep learning and let's revise the notes and everything. This weekend, we will have a quiz that covers most of the sessions, most of the services that we've treated already, but we'll have a different design or different approach. So expect a combined quiz as well this weekend. All right. So thank you all, and we want to get into today's lesson. Before I start sharing my slide and taking you into the details of DocumentDB, I want us to watch a short clip about DynamoDB, and we will compare it to DocumentDB and understand what the NoSQL databases in AWS work. So if you are here with me and you are ready, let me see ready in the chat. Let me see ready in the chat, and I'm going to share my video and we'll start right now.
You've just built a promising new app that the world has never seen before. New users are coming in, but can your database scale to handle all the requests? Amazon DynamoDB. It was built to handle internet scale applications at Amazon because traditional databases just weren't built to handle Amazon Prime Day's millions of requests per second. It's a fully managed service, so you don't have to worry about patching and upgrading your databases to the latest version. This means you can sleep in peace without being paged in the middle of the night. Not only are encryption and data recovery built in, but DynamoDB has an industry-leading service-level agreement. DynamoDB handles more than 1 trillion requests per day, and more than 100,000 AWS customers use DynamoDB. Get started today with DynamoDB, the hyperscale database for modern apps that need performance at any scale.
All right. So yesterday we were introduced to NoSQL databases, and we saw how they work, and we saw how they are built for high performance environments and operates with unstructured data. And we saw 4 different types of NoSQL databases. And if you remember any of them, please type it in the chat for me. If you remember any of them, let me see that in the chat. And these databases are super powerful and can scale really, really well. Okay. So yesterday we learned about DynamoDB, and we learned that DynamoDB is designed for key value store, NoSQL databases. It also stores documents. So today we'll be talking more about documents. Dynamo stores both key value store and document, but most of the time we refer to Dynamo as key value store most of the time, because we have another one dedicated to documents databases, and that one is called Amazon DocumentDB. So today's lesson, we are going to have a quick recap on NoSQL databases, and then we will zoom right into DocumentDB in AWS. Okay. So the NoSQL databases, we learned yesterday that they store unstructured and semi-structured data, and they are non-relational. They are designed for high performance environments, and they are schema flexible. They are schema flexible. And when we say they are schema flexible, what it means is that unlike relational databases, that when a table is designed, any data inputted must follow the same data types. You know, once you design your columns, you set the data types, every data that will come in must conform to the data type. If it doesn't conform, it will even be rejected. All right. NoSQL databases are not like that. They don't follow strict rules as in the data type you can input. So they are flexible in terms of what you can input, and they allow data items to operate autonomously. I like that. I like that. And that is really, really good. And it makes it very easy to work with it, because instead of working with, let's say, a whole table, with this, you don't have to work with a whole table. You can work with one item from the table. Okay, so every piece of record is independent or can operate independently. And so it makes it really fast and makes it very, very flexible to work with. And this makes them well suited for both vertical and horizontal scaling. We talked about the 4 types of NoSQL databases, and most of you have done really well remembering them. We have the document databases, we have the graph databases, we have the key value store, and we have the column family store, or what we call wide column databases. So these are the 4 NoSQL databases that we have. Let's talk a little bit about each one of them. For example, when it comes to DocumentDB or document databases, document databases store data as documents. So this is important. They store data as documents. Store data as document. All right, what do we mean by the store data as document? Each data item is stored independently in a format that looks like JSON. If you use MongoDB, we'll call it BSON. But this is a format. And watch this. It says each data item is stored independently as a JSON-like format, and it is called a document. Wait a minute. So if I want to store information about Jael, I have to write it in this format. See what we are getting. So ID, first name, middle name, last name, email, department. Then I will store this in the database. Now, this thing that I have stored about Jael, it is one data item, one piece of data in the database. And what happens is that this piece of data operates independently. It doesn't have to work with a whole table or a whole group. Although if it needs to work with a group, it can. But this data is stored alone. And it is called a document. So when I create a profile for someone else, let's say for Yvonne, I create a profile, first name, last name, and look at how we are saying they are schema free. Look at this document here. This one document. It gave you ID, first name, last name, email, and department. This one gave you ID, first name, middle name, last name, email, department. You know, relational databases, you can't do that. In relational databases, when we set a structure that provide ID, first name, last name, email, department, that is all will be accepted by everyone. No one can change. But with this, one person can choose not to provide or not to have certain information at all, and it works. So this is schema free. All right, so this is what we are saying. Each data item, if we are talking about products, information about one product is stored in this format. If we are talking about students, information about one student is stored in this format, and it is saved. When it is saved in the database, we call it document. Now, when we say a document, don't think of a Windows document. Don't think of a file like a Microsoft Word or a PDF document. A document in document databases that is NoSQL is just a piece of data about each data, a single data item. And it is just giving the name document because it covers information about that particular item or that particular individual or that particular record. Look at this document here. You can see that it has a different structure altogether. This makes them flexible, autonomous, and independent. Just like today, Kenya, I learned today is your Independence Day. So happy independence to Kenyans, if it is true. I was just told that, so happy independence. All right, now listen. Each document represents a single data record. And a popular example is MongoDB or Amazon DocumentDB. So not Amazon DynamoDB, like we studied yesterday. Today, we are going to learn about DocumentDB. All right, so data is stored as document. So now what is going to happen is that any new record will create a new document. This means we are going to have multiple documents. And just like the video we watched yesterday, because they are pieces, they don't have to go together. And so they can even be spread across multiple servers and scale horizontally. When you talk about key value stores, there are types of NoSQL databases that store their data as key value pairs. Unlike document databases that will store the data as a document, not a Windows file, not a file at all, it is just called a document because of the structure. This one stores it as a key and an object, or a key and a value. Now, the value can be anything. The value can be a single string. The value can be a list. The value can be a dictionary. The value can be a whole JSON-like format like the document we saw in the document. So watch this. If you look at this particular picture here, you can see that the value represents everything here, just like we saw in the previous type of database. Just that this operates with key and value. Now the value can just be a number, can be anything. As a matter of fact, listen to this. It says each key is unique. That's one thing about this. And it acts as the identifier for its associated value. Value can be anything, such as a string, a number. It can be a JSON object or even a photo. Wait a minute. You can have a key value, and the value is a photo or an audio file or a video. All right, so that is how it works. So this particular structure, the database will use a key to point to the object. Use a key to point to the object. The object can be anything. The value can be anything. And so we have multiple keys. When you advance into it, you see how some of the keys can be hash or specific values that are created in a way that cannot be replicated. This simple structure makes key value store fast and highly efficient for retrieving data. Popular examples include Redis and DynamoDB. So what we studied yesterday, it stores data in key value pairs. All right. The next one is what we call the column family store. And the column family store, they are a type of NoSQL databases that organizes data into columns and rows. Okay. Similar to a spreadsheet or a table, but what do we mean? Each row contains multiple columns. What do you mean? For example, this row, you can see that the row is a key, and beside the row, the data is created in columns. So this is what I was explaining yesterday. So you can have as many columns as you want. And all of them belong to this key. All of them belongs to this key. And so we call them a family. Please type column family in the chat for me. Column family. Column family. Now this column family, they are also free. Each column can have its own design or structure or the items it wants to store. They are not strict that you have to store name, email, and telephone, or only name. Each column can store in its own structure. So this is what we call the column family store. So instead of working with tables, with rows and columns and headers and records, this one, we have just rows. And beside the first cell, the other ones are columns of data. So each one holds a column of data. That's why they are called column family. Now, each row contains multiple columns, and each column family contains a set of related columns. So they are all related. This structure allows for efficient storage, retrieval, and analysis of large data sets. Each column family is schema-free. You see what I said? Meaning the schema can evolve without altering the database structure. Examples include Cassandra and Google Bigtable. Then, last but not the least, we'll talk about graph databases. Graph databases store data in nodes and edges, forming a graph structure. Each node represents an entity, such as a person, a place, or object. And each edge represents a relationship between these entities. This structure makes it easy to model complex relationships and navigate data efficiently. If you go on to LinkedIn, if you check the connections on LinkedIn, I have thousands of connections, and my connections are also somebody's, but some people who are my connections are connections of another person, and some of them also have mutual connections. And so we are just linked to each other to form LinkedIn. Now, graph databases are primarily used for applications that require finding patterns, such as social networks, recommendation engines, and fraud detection systems. Popular examples include Neo4j and Amazon Neptune. Now, if you look at this, I'm trying to zoom my screen. I don't know if you can see the zoom. Can you see the zoom? Maybe because of how I've shared, the zoom will not show. Can you see my zoom? Can you see that I have zoomed? Okay. You can't see. All right. If you cannot see, I understand why. Okay, so over here, let's see. I'm seeing a name here, Cameron, and I'm seeing Jerry Maguire, and I'm seeing the relationship as produced. So this is Cameron produced Maguire. And here says Cameron wrote Maguire. Then I can see, let me go here, Nora Ephron wrote When Harry Met S. So this particular data structure was found on LinkedIn, and it shows how data is stored in connections, complex connections. And this gives you an idea of how graph databases work. So this is used in the industry as well. This is used in the industry as well. For now, you should just understand how it works, and later you will get a chance to use it for applications. All right, so at this time, I just want to play a short clip or a few series of clips, and then we will jump into DocumentDB. If you are following, let me see following in the chat. Let me see following in the chat. So today we are covering the NoSQL databases. I mean, since we started yesterday, we are ending that today. If we meet tomorrow, we are going to talk about big data analytics and data warehousing with Redshift. Yes, and these lessons, we are taking them one at a time to help you digest them well, number one, and also because the materials are now being produced. So if they all existed, then we may have been tempted to cram all of them together for you, but they don't exist. They are now being created, and so we are taking it a step at a time, and I believe it is helpful and it's helping everyone understand well. All right, so let me share the video and we'll continue.
Hi everyone, I'm Yamini. So what is a NoSQL database? A NoSQL database is a non-relational database, which, unlike relational databases, does not store its data in tables with fixed columns and known data types. Instead, it uses documents with data type descriptions and values to store data. A NoSQL database has a dynamic schema for document types. What this means is you do not have to explicitly mention the form of your data before storing it. So this kind of database can handle unstructured data really well. NoSQL databases use a hierarchical data storage. So as your application grows and you start to add new fields, your schema evolves as needed. So this database is scalable horizontally. So if you need to build something really quickly or are in early stages of prototyping a new application, NoSQL is a good way to go.
Hello people! You might have heard about SQL, which is a structured query language used to extract data from a relational database. Relational databases are usually stored in the form of tables, but in the real world, we want to store data in the form of documents, trees, and even graphs. This is where NoSQL, or not only SQL, helps. As the name suggests, NoSQL databases store the data in non-tabular formats. There are various types of NoSQL databases. Let's check them one by one. Key value database stores the data in form of key value pairs. The database contains unique keys and the values associated with those keys. We can query the database by passing the key, and the database will return the value corresponding to that key. BerkeleyDB, Dynamo, and Redis are some examples of key value databases. This type of database is often used for caching data. Wide column database stores the data into flexible columns, which can be spread across different servers. The query to find specific column values can be executed very fast. That is why it is also called a column-oriented database. Cassandra, Google Bigtable, and HBase are examples of wide column databases. This type of database is often used to store time series data. Document database stores data in the form of field value pairs. Values can be of any type like string, number, date, array, or even object. Document can be stored in the form of JSON, BSON, or XML. Amazon DocumentDB and MongoDB are examples of document databases. This type of database is often used to store PDF files in the form of JSON for better querying. Graph database stores data in which entities are related to each other. Information for entities is stored in the nodes of the graph, and the relationship between entities can be stored along the edges. Amazon Neptune and Neo4j are examples of graph databases. This type of database is often used for social networking applications. Overall, NoSQL is a very powerful paradigm for databases, and it is easier to scale. I hope you found this video helpful.
MongoDB is the world's most advanced and popular document-oriented database. It was created in 2007 after the team at DoubleClick, a company serving 400,000 ads per second, faced issues with scalability and flexibility using existing database systems. This inspired them to design a database where all data is stored in JSON-like documents, which are organized into collections where they can be queried. Unlike a relational table, a predefined schema for a collection is optional, which allows you to evolve your data structures rapidly without running complex database migrations. But more importantly, it allows data that's frequently accessed together by an app to be stored in the same place. This makes read operations extremely fast because no joins are required. It's like having a fully assembled car ready to go as opposed to joining together a bunch of separate parts. And that also makes the database much easier to scale horizontally via sharding. Unlike relational tables, collections are self-contained, making them much easier to work with in a distributed system. That's why they call it Mongo. It's designed for humongous workloads. When you create a new document in MongoDB, it's assigned an object ID that's unique to that collection. Inside the document, you can define multiple fields, where the value might be a variety of different data types like a string, array, object, and so on. Now, to work with your data in any programming language, the Query API is used to perform basic read and write operations, as well as complex queries and transformations across the database. To optimize performance, secondary indexes can be created to make common queries extremely fast. It also supports geospatial queries to find all the documents near a geographic location. In addition to queries, you can also create data aggregation pipelines, which can group documents together and reduce them to a single result. MongoDB is free to use and can be self-hosted, but the quickest way to get started is with the free tier on Atlas. It scales automatically and provides a UI where you can interact with your data, plus a ton of other awesome features like full-text search that leverages the power of Apache Lucene. In addition, they just launched a serverless option where you only pay for the exact resources that you use. And Atlas has other essential features like triggers that make it easy to run serverless functions when your underlying data changes. Then there's Realm, which is a Firebase-like platform that makes it easy to sync up your data with a front-end application in real time. This has been MongoDB in 100 seconds.
All right. So just like AWS designed Amazon Aurora for compatibility with MySQL and PostgreSQL, they have also done the same here with DocumentDB. This DocumentDB is designed to be compatible with MongoDB. So DocumentDB is a fully managed NoSQL database service on AWS that supports MongoDB, one of the most popular NoSQL database systems. When we studied about EKS, we learned how AWS has built their infrastructure and their service EKS to be compatible with the most popular Kubernetes. Also, Aurora has been built to be compatible with the most popular MySQL and Postgres. And DocumentDB has also been designed to be compatible with the most popular MongoDB. It provides scalability, high availability, and security, all managed by AWS. It is a fully managed service, making it an excellent choice for developers who need the power of MongoDB, but prefer the convenience of a managed service or a fully managed service. Amazon DocumentDB, please type DocumentDB in the chat for me. This is not DynamoDB. This is DocumentDB. Let me see DocumentDB in the chat. DocumentDB. Let me see the first person to type DocumentDB. And I'll see who can type it the right way. So Ruben was number 1. Valentine Adewumi. Like Adewumi has a space in it. But AWS didn't put space. Google it too. It's been a while since I heard Google's name. So Luke Bokola. Adewumi has corrected. Frida. All right. So this is DocumentDB. And it is designed to handle complex document structures, allowing for a flexible schema, indexing, and query capabilities. So all those with experience in MongoDB, you can import your MongoDB applications to AWS and host it in DocumentDB without making any changes. Just as you can host your MySQL in Aurora, you can also migrate your MongoDB database to AWS. And where will you keep it? Amazon DocumentDB. That is where you keep your MongoDB, because DocumentDB has been designed to be compatible with MongoDB. What's the difference between DynamoDB and DocumentDB? A few things we should know is that DynamoDB is both key value and document. So it follows a key value and document model. This type key value and document model. That is what Dynamo does. So Dynamo supports documents, databases, and also supports key value. Thank you, Frank. It is fully serverless and provides extreme scalability for high throughput workloads. All right. If you look at DocumentDB, one thing you are going to discover is that DocumentDB is designed for the document model only, designed for operational workloads with MongoDB compatibility. So this is where we find the difference. DocumentDB is for the document model only and designed to be compatible with MongoDB. So it was created for MongoDB, just as we had ECS, Elastic Container Service, for containerized applications. We also had EKS just because of Kubernetes. That same way, we have DynamoDB for NoSQL, but then we have DocumentDB specifically for MongoDB. The key features of DocumentDB. Number one, compatibility with MongoDB. It is fully compatible with MongoDB APIs, allowing you to run MongoDB applications without change. So in the examination, anytime we are talking about databases and you hear MongoDB, you should think about DynamoDB. Scalability, easily scale up storage and input-output resources to handle increased workloads. High availability provides multi-easy deployment with automatic failovers, ensuring minimal downtime in case of failures. So it provides multi-easy deployment with automatic failover. All right. So this is how they provide high availability by replicating data across multiple AZs. Then when it comes to security and encryption, okay, let me check something. Okay, so we are talking about DocumentDB, okay? That's why I asked you to type DocumentDB. All right, so let me check that. It was just one small typo. AWS is doing so well, and their services are so interesting. All right. Automated backups. So we have Amazon DocumentDB automatically takes daily backups with a retention period of 35 days. So please keep this in mind. So backups are done every day and will be retained after 35 days. What it means is that 35 days old backups are going to be deleted the next day. The new backups will also be coming in. And this is done automatically. So these are automated backups. Then we have monitoring and alerts. It offers built-in monitoring and customizable alerts to track your database's performance. So some of these things, anytime you hear monitoring, you should be thinking about CloudWatch. Please type CloudWatch in the chat for me. CloudWatch, CloudWatch. All right, so some people are going to take the examination, so they need to hear a lot of things. Then cost management allows you to choose between on-demand and provision capacity, enabling cost controls depending on your workloads. Now, we need to understand that there are compute behind the databases, and there is storage as well behind it. So, because it is fully managed, it is going to, AWS will take care of the provisioning of the servers and everything. However, based on your need, you may have to provide a lot of settings and you have a lot of options. So one of the options here is to allow you to choose between the EC2 instance you want, or to let you choose the compute that you want, to allow you to save based on how you intend to use your application. All right, so at this point, we are going to watch one clip about DocumentDB, our last clip for today. And after that, we'll talk about either one or two other points, and then we will be done with the information we need on DocumentDB. So let me share the video and we'll watch that short clip.
Amazon DocumentDB with MongoDB compatibility is a fast, scalable, highly available, and fully managed document database service. DocumentDB is designed from the ground up to give you the performance you need when operating your critical document database workloads. DocumentDB makes it easy to insert, query, index, and perform aggregations over JSON data, allowing you and your development team to iterate faster and be more productive. It is MongoDB compatible, so you can use the popular MongoDB API to query your documents, and you can use your existing MongoDB drivers and tools. As a fully managed non-relational database service, DocumentDB automatically handles the undifferentiated heavy lifting of database management, like configuring high availability and durability, patching, monitoring, and backing up your cluster. It gives you performance at scale because the storage and compute are decoupled, allowing each to work independently. You can scale your compute in minutes, independent of your data size, so that you can quickly optimize for your workload. You can use AWS Database Migration Service at no cost for 6 months to easily migrate your on-premises or Amazon EC2 MongoDB databases to Amazon DocumentDB with virtually no downtime. Get started with Amazon DocumentDB with MongoDB compatibility today.
All right, please type AWS Database Migration Service into bracket DMS. Please put that in the chat for me. AWS Database Migration Service into bracket DMS. All right, so AWS has a lot of services that we should know about. Now, let's talk about the use cases of DocumentDB. All right, so number one, we have Content Management System, CMS. Examples include blog platforms or knowledge-based platforms that store complex document data. So any CMS that stores its data in the document model, we use DocumentDB. Then we have mobile and web applications. Examples include applications requiring fast and flexible access to JSON-like documents. So mobile and web applications that requires fast and flexible access to JSON-like documents. So there are some web applications, they store their data in JSON-like formats. Like a lot of modern applications, web applications are built using MongoDB. And so data is stored in this particular format. Then we have catalog management. Examples include e-commerce platforms with dynamic, semi-structured data for products. All right, so any application that stores data in the document format, or any modern application that adopts this model of data storage, will use DocumentDB. When it comes to billing and pricing, you are priced by the compute you use based on the instance type and the size. So you need to select the instance type you want because there's compute within it. Also, we have storage based on the actual storage you consume. So you are billed based on the storage you consume, based on your instance type, your storage. Then when they are snapshots or backups based on snapshots, storage beyond the free tier. All right, so when it comes to snapshots, we need to remember snapshots when we learn about EBS, Elastic Block Store, that it takes snapshots. And we learn that EBS, because of the block storage structure, is what is used for databases. So all the database services we have covered, we should think of them as storing their data using EBS. And of course, if they are using EBS, then the snapshots will also take place. So for all the database services, their backups are done using these snapshots. All right, so in terms of pricing, snapshots taken beyond the free tier will be billed. Then the free tier itself, DocumentDB is not included in the AWS free tier. All right, so DocumentDB itself is not included in the free tier. When it comes to cost savings, best practices could be selecting the right instance sizes or the instance type, or using what we call reserved instances. So we've talked about the instance types and their pricing models. So the reserved ones, because you reserve and you pay upfront, you get to save a lot. Who can remember the percentage for reserved instances? How much do you save if you can reserve up to 3 years? How much do you save? Anybody? Anybody? If you can reserve, okay. All right. Okay. Thank you. Thank you. All right. So, ladies and gentlemen, this is where we end our lesson on DocumentDB. Let's add it to what we've learned. And please tell me one thing you've learned today. Let me hear one thing you've learned. You've learned today, and we will end the lesson. So what did you learn about DocumentDB? Just tell me one thing you learned today. All right. So first person, DocumentDB is MongoDB compatible. Okay. That's good. Any other? That's very good. So DocumentDB uses the document model only. That's very good. That's very good. Who else? Let me think about 5, then we'll close. It has no free tier. Thank you, Hilary. Then there are use cases for web applications, CMS, and cataloging. Wow, thank you, Lois. That's good. One last one, and Yampandi says it is compatible with MongoDB. I think someone has said that already, but it's good. At least that's one good thing to learn from this, and it is fully managed. All right, so that's wonderful. Thank you all. Thank you all. It's been great. It's been great learning with you. We'll keep on learning. We'll keep on learning. Next week is going to be our final week of learning in class for the year. And tomorrow we may have a class. For the juniors, you'll be given access to certain courses that the seniors have taken that you would have to take. And the announcement will come next week, so you get it well. So before we break for the end of year vacations. Next week is going to be our final week of learning for this year. So next week, we'll cover the rest of the content that AWS requires, and we will be done with the course. And everybody will be ready. So once it's time for you, you go and pass the examination. Thank you all. Have a wonderful day, and I'll see you, God willing, tomorrow. All the best. Bye-bye.